All right, hello everyone. Thanks so much for joining us for Integrated Manufacturing today, a part of our What's New in Solid Edge ST9 webinar series. My name is Diana Dietrich. I'm the marketing specialist here at Swoosh Technologies, and I will be your host for today. So just a little on Swoosh. For over 11 years, our team has been dedicated in providing you the best software solutions, technical support, and process-based training to help you design and manufacture better. Our commitment to changing the way designers and manufacturers learn and leverage PLM tools has been a major focus for us and will continue to be our goal moving forward. Presenting today is Senior Application Engineer Joe Gesualdi. Joe's career is deeply rooted in manufacturing and machining, and he knows what is needed to keep your workflow going, and his hands-on experience in holding positions such as machinist, CNC programmer, and CAD CAM supervisor has really shaped the way he helps a lot of companies. It also allows him to show manufacturers and job shops best practices and solutions needed to really accelerate their workflow. Today, we're talking CAM and Solid Edge. ST9 brings the best of Solid Edge's leading embedded CAM solution for a variety of manufacturing needs. That way, you're going from synchronous technology to manufacturing instantly. Joe's going to be showing us how you can bridge the gap between CAD and CAM with Solid Edge's built-in integrated solution. So if you have any questions during the presentation, please feel free to please feel free to add these into the questions box located in your GoToWebinar panel. Joe's going to have your questions answered during the Q&A portion taking place right after the presentation. So I'm going to go ahead and send this on over to Joe, and he will take it away.
Thank you, Diana. Good afternoon, everybody. My name is Joe Gesualdi. I'm a Senior Applications Engineer with Swoosh Technologies, and today we're going to take a look at what's new in Solid Edge ST9 with CAM Express, Siemens solution for computer-aided manufacturing. So for those of you that are unfamiliar with CAM Express, it has a wide range of capabilities. So we can do everything from 2-axis to 4-axis turning, 2.5-axis to 5-axis milling. We have capabilities for turbo machining, mill turn, wire EDM, feature-based machining. We can also do things like all-machine probing, machine tool simulation, where we can actually verify the machine code that's coming out of NX so that we make sure that we're not having any issues with over travel or collisions. In this latest release of CAM Express 11, Siemens has invested in new technologies like robotic machining, hybrid additive manufacturing, and line designer, where we can actually develop a manufacturing assembly line and simulate it. Along with CMM inspection, where we can develop high-speed inspection programs, develop programming automation, and clear visual results. We've also redeveloped and enhanced functionality for things like mold and die machining, production machining, complex parts, and even shop floor connectivity. So, new and innovative technologies to transform your manufacturing operations and to meet new and ever-changing market demands using the latest manufacturing technologies. So, a manufacturing challenge, expanding machining flexibility for things like trimming, deburring, grinding, and polishing. Machine tools can be overqualified to do these simple tasks, and manual processes are time-consuming and imprecise. So consider robots. They have a large work envelope. They're relatively inexpensive compared to multi-axis complex machining centers. They are multi-axis equipment. Most have 6+ axes. And they're typically hard to program for precise 3D tracing motions. So I'd like to introduce robotic machining with CAM Express, where we can utilize robots for machining style motion. Large envelopes are easily covered, and we can trace contour ports for deburring, grinding, and polishing. We can employ robots to perform these light machining style tasks in your work cells and boost productivity. Apply robots to precise machining style tasks often done manually, trimming, polishing, deburring, etc. Select 6+ axis industrial robot configurations as a machine tool for simulation, so we can verify everything inside of CAM Express. Provide special axis controls to obtain preferred positioning solutions. Simulate final machine motion using the most powerful NX simulation technology. And we can post-process CAM toolpaths to robotic machines. So you can see here we can expand the application in which we can use robots. As I said before, the big three: deburring, polishing, finishing, and trimming. We can use them to improve productivity, so we can increase flexibility, get better repeatability and higher accuracy. And then we can also fully automate your manufacturing process. So we can create complete work cells in which we have machine tools where robots are taking parts and putting them into machining centers and unloading and whatnot. So we can utilize robots for multi-purpose functions using proven technology. Another manufacturing challenge is the need to create impossible geometry. Some designs are impossible to make. Designers and engineers want interior features, things like 3D tooling channels for aerospace and tooling, mold design. Others are things like internal lattice features for lightweighting parts while also maintaining the strength and durability. And casting these parts often create long lead times. Castings can provide some complex geometry, but they have a long lead time and limited ability to iterate designs for improvement. So instead of waiting for castings, we can print a few. So introducing hybrid additive manufacturing, where we have both additive and traditional machining capabilities within the same machine. And with CAM Express, we have the ability to create completely new designs with speed and precision. We can drive the latest hybrid additive machine tools, things like the Morisiki laser tech. We can build components in any direction using 5-axis machine tool configurations, which minimizes the need for support structures. And then we can utilize traditional machining at any step to precisely machine critical features. So we can create new part designs with internal cooling channels, lightweight lattice structures, and even alloy variations. We can even print multiple materials. We have faster builds because we utilize multi-axis capability, so we have direct deposition, we can eliminate support structures, and we can build in any direction. And precision. We can precisely machine surfaces at any time during the build, even internal cavities. So those are some of the new and innovative technologies that Siemens has been investing in its computer-aided manufacturing solutions. Now let's take a look at some of the new things that have changed inside of CAM Express with the more traditional manufacturing processes. So as I said before, a wide range of capabilities from turning to milling for those of you that aren't familiar with CAM Express. So with CAM Express, when it comes to mold and die and complex part machinings, all the improvements have allowed us to machine higher quality parts. Improvements that have been made in this version of CAM Express are things like getting better results in corners. We're creating higher quality toolpath, smoother toolpath, so that we can improve the surface finish quality when we're machining things like corners and things like molds and dies. We're also generating higher quality toolpath on surfaces even with imperfect imported geometry. So we're creating toolpath that is generated on the surface and stepped over on the surface versus generating projected toolpath and projecting it onto the geometry, which can cause some issues, especially when you have surfaces that are just slightly misaligned. We're generating toolpath faster than ever. Our toolpath has been optimized for multi-core processing to better take advantage of multi-core hardware. Calculations can be generated as much as 50% faster. We're able to update multiple toolpaths faster by regenerating only operations that are out of date. So we could select a toolpath group that could contain 100 or so different operations, and if only 20 of them are out of date, we can select the program group, say regenerate, and it will only regenerate the operations that are out of date. And we update our non-cutting moves faster. We've now separated the generation of the cutting moves and the non-cutting moves. And if you need to make a change to a complex toolpath that say it has thousands of lines of cutting motion, we can regenerate the non-cutting moves up to 10 times faster. The integrated simulation and verification side of CAM Express has been enhanced to allow us to immediately validate our results by suppressing the graphics, which allows us to generate our results up to 7 times faster. We can easily validate 5-axis machining behaviors. We can visualize and use tools to analyze toolpath characteristics to see things like lead angle, swiveling axis with machines that have A and B limitations, rotary axis speeds to detect reversals, and also see short and long segments. Continued updates to CAM Express have allowed us to efficiently create programs to manufacture prismatic parts. With those enhancements, we can program holes faster. Continued updates to hole making over several releases have allowed us to improve productivity. Using hole making, we can either select the machining area or we can allow CAM Express to recognize those features automatically for us. Hole making allows us to have graphical feedback of in-process material so that we can see what's being removed and what still needs to be removed on our work part. Comprehensive non-cutting moves work with multi-vector hole cutting, so it allows us to easily machine multi-axis holes around a part. We have advanced associativity, which allows us to quickly regenerate our part when changes happen, and we can program 60% faster with these new methods. Enhancements to hole making operations inside of CAM Express include the deep hole drilling operation, which automatically detects cross holes and determines if they've been machined. Back countersinking operations, which position specialized tools for insertion through holes and then control the spindle. Chamfer milling operations, which allow us to machine chamfers on holes that are either modeled or unmodeled. And radial groove milling, which uses the hole milling approach to provide circular with radial and axial stepovers as needed to machine circular grooves. With hole making, we can reduce machining time easily. We can group hole making operations for optimization. We can combine tool paths to minimize engages. We can resequence holes to avoid lifting over obstacles. And we can provide favored start locations for combined tool paths, all while full collision checking remains in effect. Additional enhancements to feature-based machining inside of CAM Express allow us to increase the flexibility of your feature processes by defining machining variations for feature processing directly inside of the CAM Express user interface and create rules without using the machining knowledge editor. This allows us to stay inside of the CAM Express interface and not switching back and forth between a different environment to make changes or add additional rules to our existing feature-based machining database. Enhancements to CAM Express for shop floor connectivity allow us to connect planning and production easily. We can create posts directly within CAM Express. Post layers within Post Configurator provide modular programming. The base, controller, and customer layers provide the desired customizations without disturbing formats required by the controller. You can use the kinematics directly from the machine tool builder to apply the kinematics within post processor. There is an embedded TCL file editor for flexible customization of the post processor and provides full mill turn support. With Work Instruction Author inside of CAM Express, we can create comprehensive work instructions as you create the NC job. You can provide each instruction item as a unique view of the setup. You can easily include boilerplate items and quick pick text. You can create links to external references. You can publish to PDF or HTML, and you can automatically update work instructions to reflect geometry or toolpath changes. DNC Connect allows you to connect your native CAM Express system to the shop floor DNC system to take advantage of shop floor data and process management, even without a full Teamcenter installation for CAM Express. It allows you to search and visualize managed data. Work package hands off to Shop Floor Connect machine tool clients for DNC. For those of you that are unfamiliar with CAM Express and how Solid Edge interact, I'd like to do this brief demonstration on this part and fixture assembly that I've created inside of Solid Edge. Here you can see that we have our part and our fixture assembly inside of Solid Edge. To bring this into CAM Express, we'll go to the Tool tab on a ribbon bar and then click the CAM Express button. As you can see, our part has been successfully brought into the CAM Express environment. Status says Operation Succeeded. From here, I'm going to open up an existing assembly that has a machine simulation kit already pre-built. I'll select the assembly file and then say OK. CAM Express displays information and tells us that it successfully loaded the machine simulation kit and loaded our tools. We'll zoom out so that we can see the entire machine simulation kit. Now we're ready for part programming. I'm going to create an operation where I want to machine this groove inside of here. To do that, we're going to use the groove milling operation. We'll select our tool because I've already have created a T-slot cutter inside of there. Select the correct geometry, our workpiece, and we'll even specify a method to finish the groove. Optionally, if we wanted to, we could specify a name, but for now, I'm just going to leave it at groove milling. With the groove milling dialog, I'm going to specify the groove geometry. I simply have to select one face of the groove and it will find the groove geometry. As you can see, it's been displayed right here. From here, we can generate the toolpath and see what it looks like. As you can see, we have a toolpath. The blue is the cutting motions, and the yellow and the white are the engage and retract. I don't quite like how linear the non-cutting moves are, so I'm going to go change them from linear to arc using the non-cutting moves options inside of the operation. We'll change the engage type from linear to arc. Specify a radius of 50% of the tool diameter. Give it an arc angle of 90 degrees. And then I'll also go to the retract to make sure that the type is set as same as engage. I'll regenerate the toolpath, and you can see that we have a nice arc in and out motion. We can go in here and we can verify the toolpath using our 3D dynamic. Slow down the toolpath and hit play so we can visualize the material removal. As you can see, the material has been removed from our in-process workpiece. Next, I'd like to machine these holes. To do that, we're going to use our Find Features command. We're going to allow NX to find the features on the part and then also allow them to automatically generate the operations for us. As you can see, it has found all these holes, and in the dialog they're selected, and you can see that they're displayed here in red in the graphics window. From here, if we go to our machining feature navigator, we can select the features that have been found, and we can use the create feature process command to automatically create the operations and select the tools to generate the toolpath. Within the create feature process dialog, I can filter out the types of features that I want to create operations for. For now, I'm just going to select OK and generate features that I've found. When we go to our operation navigator, you'll see that a spot drill operation and a sequential drilling operation has been created. When I generate these operations, we'll be able to see the resultant toolpath. As you can see, the toolpath has been successfully generated. From here, we can verify the work that has been done so far. We'll use the verify toolpath command to verify what has been done. As you can see, the slot and the holes have been successfully machined. Lastly, I want to machine the slot on the opposite side of the part. To do that, we'll use a planar mill operation. Inside of the operation, we'll specify the necessary things in order to create the toolpath, one being an edge to drive by. So I'll select the inside corner of this groove and specify some of the other necessary things needed to drive the toolpath, one of them being a floor. So we'll specify the floor, change our drive method to profile so we can profile along that, and we'll generate the toolpath. As you can see, I have a straight linear toolpath. I don't exactly like how that toolpath is, so I'm going to change the non-cutting moves. Once again, we'll change them from linear to arc. Change the radius to 50% of the tool, and then regenerate the tool path. As of right now, it would machine all material in here in one pass. So I need to specify multiple stepovers. We have various options, one of them being multiple. I'm going to specify multiple paths in order to machine this slot. In this area, and then set it up so that it'll skip here and only machine this area. Going to regenerate the toolpath, and you can see that I've created multiple offsets in order to machine this. When we verify, you'll see that it'll remove material in the right areas. As you can see, is removing the material. From here is where we can use machine simulation to verify the toolpath. To do that, we'll use the machine simulation command, and I'll zoom out so that we can see this more clearly. In the visualization options, we're going to change from machine tool or machine path simulation to machine code. And you can see that it has warned us that we have two tools that are using identical numbers. Okay, so we'll quickly back out of this and we'll go to our machine tool view and take a look at our tools. And I'm just going to slightly reorganize them. And as you can see, as we reorganize our tools, they move around in pockets as well. Now that we've rearranged our tools, let's go back into simulate machine and simulate the machine code. Hit the play button, and you can see that it's verifying the actual machine code that's been simulated. Now that we're done, finished programming a part, let's throw in a scenario that almost never happens. So we have a design engineer that makes a change to the part. Now that we've got our completed part program, how do we handle, an ECO or engineering change order? So all we have to do is simply go back into Solid Edge, and let's pretend that I'm the designer that's making this design change. So let's go in and do an in-place edit of the part. Say, I need to make this groove, the slot just a little bit wider. So say like 5 millimeter. And then say I need to move all these holes just a little bit further out. So I'm going to select all these holes real quickly. And I'm just going to move them say 2 millimeters, just enough to throw them off. So close and return, and we'll save the assembly. So we've changed the size of the slot and we've moved the holes. So what do we do next? We simply have to select the CAM Express button, and as you can see, it's updated the part. It's told us it's been successful. CAM Express tells us that the operations are out of date. All we have to simply do is select Generate and regenerate all of the tool paths. So you can see it's regenerated the path for this slot. Just regenerate the holes, and it's going to regenerate the path for planer mill. Now that we've regenerated all of our machine code, we can go back and re-simulate the entire manufacturing process. So we'll use the simulate machine command and select the play button. And this time, I'm going to do it with 3D material removal so we can see the material being removed. As you can see, it's running through the simulation process. And we've successfully simulated the code without any hiccups. If you'd like to learn more about CAM Express or NX manufacturing, you can visit these websites online. There's a manufacturing forum. You can also go online at Siemens.com, PLM, NX11, and there's also a Manufacturing 360 tablet application. That's all I have as far as the presentation, and I'm going to throw it back to you, Diana.
So it's time for our Q&A portion. So we do have a few in the queue today, but I just wanted to let you know that if your question is not answered during this live session, I'll make sure to send it over to Joe immediately following this presentation, and he'll get back to you in the next few days by phone or by email. So Joe, the first question that we have in our queue is, does CAM Express need to be used with Solid Edge, or is it CAM neutral?
No, it's CAD neutral. So if you have data from SolidWorks or CATIA or ProE, wherever it be, we can bring it in and we can open it up and we can work with it.
And then we have one final question for you. What if I need to do more customization to my assembly in Solid Edge? Will it immediately show my updates when I click the CAM Express button?
Yes, absolutely. Any changes that are made inside of Solid Edge can be easily reflected just by hitting that magical CAM Express button.
All right, thanks, Joe. So I'm going to turn it back to myself. So we hope you enjoyed today's session, guys. As a reminder, if your question wasn't answered or you're getting ready to throw in a question in there, please know that I'll get them all over to Joe, and he'll reach out to you by phone or by email. So that way your question will be answered. Once again, guys, thanks so much for joining us today. We hope you enjoyed it. We hope you can join us in 2 weeks for 3D modeling. It is on Wednesday, October 19th at 2 p.m. Central Time. Dylan will be showing us how ST9 has improved the 3D modeling experience with even more speed and flexibility. So if you haven't registered for that yet, please be sure to do so by registering whenever the replay email goes out, or by hitting your or by going to the URL listed on the screen that you're seeing right now. Also, if you do have any questions regarding, CAM Express or and Solid Edge, please feel free to reach out to me or Joe by phone or by email. We're more than happy to help. If you're already in touch with one of our Swoosh representatives, please feel free to reach out to them as well. Either way, we're all here to help you meet your business goals and do what we can for you. All right, thanks so much, guys. Thanks, Joe. Bye.
Hey,